Hello everyone, welcome to NS Academy, and in this video you're going to see all the solved problems from IIT JEE and JEE Advanced from 1983 to 2024 of definite integration. I solved them and I have explained each and every one of them. So this video is going to be an educational one and also kind of a challenge because I was not really looking at the solutions. I was at the board and my friend helped me get all the problems. He told me one by one, I had solved it, and this was a video made with the purpose for you to learn how to solve directly in the exam hall when you're given such a problem. You will see my thought process, you will see how I actually solve problems, and it's going to be, I think, very helpful for you guys. So let's begin. Okay, what is the first one?
Find the value of the integral 0 to 2a
0 to 2a
fx whole divided by fx plus f of 2a minus x dx.
And here?
Year 1988.
Okay, so this is our first integral, f of x divided by f of x plus f of 2a minus x, 0 to 2a. Name this integral I. Apply the formula of a to b f of dx equals to a to b f of a plus b minus x dx. If you do that, you will get f of 2a minus x here. You will get f of x plus f of 2a minus x dx. Now notice this is also I. Add these two copies of I, you will get 2i equals to 0 to 2a. When you add these two integrals, you will get numerator as the same as the denominator, which will cut off to give you 1. Cancel the 2's, you will get I equals to a. Simple as that. This is our answer. Great. Yeah, second one.
Integral of 0 to 1.5
0 to 1.5.
Greatest integer function
Greatest integer function
x square dx.
Okay.
Year 1988.
So this is the second question, 0 to 1.5, GIF of x square dx. Now in GIF functions we need to divide the integration in such intervals such that the expression inside this GIF is between two consecutive integers. Well, first of all we will try it with 0 to 1, integrate greatest integer function of x square dx. Now we will not go from 1 to 1.5, rather we will go from 1 to root 2. This is because x square, x between 1 to root 2, if there is x square will be between 1 to 2, right? And root 2 is approximately 1.414, which is less than 1.5, which is where we are going to 1 to root 2. This plus root 2 to 1.5, this. Now inside each of these integrals you can see that x square is the GIF of x square in 0 to 1 is basically 0. The GIF of x square in 1 to root 2 is basically 1, and 1 into integral of 1 to root 2. And then again in this root 2 to 1.5, this is root 2. Actually this is 2. 2 dx. X square is basically 2. You do this, you get root 2 minus 1, and here you get 2 times 1.5 minus root 2. This gives you root 2 minus 1 plus 3 minus 2 root 2, and this gives you, I think, 3 minus 1 2, 2 minus root 2, which is your final answer. And that's how you solve this kind of problem. So let's go to the next one. Yeah, number 3.
Integral of minus 2 to 2
Yes.
mod of 1 minus x square dx.
Mod of 1 minus x square dx.
1989.
1989.
Yeah.
Right, okay, so first of all, even function, apply the rule, 2 times 0 to 2 mod of 1 minus x square dx, correct? Now, we again have to break it into intervals such that this is either positive or negative, correct? So 2 times 0 to 1 mod of 1 minus x square dx plus 2 times 1 to 2 mod of 1 minus x square dx. In 0 to 1, this is, if you can understand, since x is from 0 to 1, 1 minus x square is positive. This. Okay, so this is 2, 1 to 2. I think this is now negative because from 1 to 2 this basically becomes negative. So we will have x square minus 1 rather. Okay, 2 times. Now you can do this. 0 to 1, 1 is 1. 0 to 1 x square is 1 by 3. 1 to 2 x square is 2 cube minus 1 cube, which is 7 by 3, correct? Minus 2 minus 1 is 1. So 2 minus 2 by 3 plus 14 by 3, and I think minus 2. Correct? 2 minus 2 by 3. And 14 minus 2 is 12 by 3, which is, I think, the answer is 4. and this completes the third part. Yeah, number 4.
Integral of pi by 4 to 3 pi by 4
3 pi by 4, yes.
x
X
by 1 minus sin x
1
plus sin x
1 plus sin x. Okay.
dx 1993
1993
93
JEE. Okay. Again, we have this thing. We are going to apply the same formula again. A to b fx dx equals to a to b f of a plus b minus x dx. Name this as I. Then I would be equals to pi by 4 to 3 pi by 4. Pi minus x. Add this to this becomes pi. 1 plus sine of pi minus x. Well, obviously this would give us pi by 4 to 3 pi by 4. Now, do the distributive law here. Sine of pi minus x is simply sine x. So 1 plus sine x dx minus the integral that you get is simply I itself. Do this to get 2y equals to pi by 4 to 3 pi by 4, and you have dx by 1 plus sine x dx, and there is a pi here, right? Okay, we'll continue it here. Let me erase this part here. And then I would be equal to pi by 2, pi by 4, 3 pi by 4. Now, this dx by 1 plus sin x, we can multiply 1 minus sin x up and down. Okay, so obviously this one has an antiderivative, so now we can erase this one. Pi by 2, pi by 4 to 3 pi by 4, 6 square x dx, minus pi by 2 into integration of pi by 4 to 3 pi by 4 sin x by cos square x dx. This is tan x, so this is tan of 3 pi by 4 minus tan of pi by 4 is, notice the derivative of cos x is sin x, so we can write this as d of cos x and make this plus. Okay, now we can continue it here. I then would be equal to, this is minus 1 minus 1 minus 2, this is plus pi by 2, and okay, this is minus 1 by cos x, which is minus sec x, and because the derivative of 1 by cos square x should be minus 1 by x. Okay, so this is minus 1 by cos x, which is minus sec x, so basically sec pi by 4. Sec pi by 4 is root 2, and this is, I think, sec of 3 pi by 4, which is again like root 2 but not on the negative side, so this, so 2 root 2 by 2 is root 2 pi, so pi over into root 2 minus 1. That is your answer. Number 5.
Integral of 1 to e to the power 37
1 to e to the power
37 pi sin pi ln x
pi sin pi of ln x
pi of ln x by x dx 1997
1997. Okay, so we have this integral, and instead of, notice that log x and its derivative dx by x is present. So set this so that you have dy equals to dx by x. Okay, then your integral basically becomes, so the limits 0, ln of e to the power 37 pi into sine of pi y divided by this dx by x, and I think everything cuts up obviously, so dx by x is dy. Pi is outside, integration of sine of pi y should be minus cos of pi y from 37 to 0. Now this is 1, you basically have minus cos this plus cos 0, which is 1 minus cos of 37 pi. Now, in terms of 2 pi's, 36 up to 36 pi, we have the same rotations. One more pi again, so cos pi is basically minus 1. So this is number 6.
0 to pi by 4 sin x plus cos x whole divided by 9 plus 16 sin 2x dx. Year 1983.
Okay, so we have now this integral. Again, this might look a bit complicated, but it's also similar. Why? Like this. So make the numerator, make no changes to the numerator basically, because I have already noticed a sin 2x here, which is basically 2 sin x cos x, right? So what you can do here is this. You can write 9 as I think 25 minus 16, and then take the minus 16 common to write 1 minus sin 2x. Okay? This would give you 0 to pi by 4 plus cos x divided by 25 minus 16. Now 1 is basically sin square x plus cos square x, and sin 2x is 2 sin x cos x, which gives you this. Set this as y. If this is y, then this part is dy. Okay. If this is y, then and now the limit should be cos 0 minus sin 0, which is 1, and cos pi by 4 minus sin pi by 4, which is 0. And I think you get and the differentiation is dx of cos x minus sin x minus cos x, so there would be a minus sign, and you have dy divided by 25 minus 16 y square, which is nothing but 0 to 1 dy by 25 minus 16 y square. Correct? Now this is of the form, I think, a square minus y square, like that. So we'll first take 16 common here, and we will have 1 by 16, 0 to 1 dy by 5 by 4 whole square minus y square. This gives you 1 by 16, and now this is a formula, I think very similar formula, where you have to break it into a plus y into a minus y, and then do the 1 by 2a thing. So basically 1 by 2 into 5 by 4, and then this basically becomes ln of, so a minus y by a plus y, so 5 by 4 minus y is 5 by 4 plus y from this. So erase this part. So this basically becomes, take a
Start. To frame lag code just start kar.
Okay, so this would be, and this 2 and this is would be 8, 1 by 40, 1 by, if you put 1 here, first of all, you can make 5 minus 4y by 5 plus 4y, gets you 1 by 9, and if you put, you get a number. This basically gives you 40, or in other, this is 3 square, so 2 and 3 by minus and 3 by 20 should be your. Next.
F of x, a sin pi x by 2
A sin of pi x by 2
plus b f dash x half
f dash of half
is equal to root 2
root 2
2a by pi 0 to 1 integral of 0 to 1 fx dx. You have to find a and b.
Here
You have to find a and b.
yeah, no, the year in which it
1995.
1995.
Yeah.
Okay, so we have this problem where we have f of x given, f dash half given, and some integral given. Okay, this is a pretty easy one, you would see, because first from this one we can do this one actually first. 2a by pi equals to 0 to 1 this a sin of pi x by 2 dx plus 0 to 1 b dx, which is nothing but b. This would give you 2a by pi equals to 0 to 1 a. Actually, let's do it like this. A into this, we can simply do it directly, because this would be 2 by pi, and inside you will have cos of pi x by 2 from 1 to 0 plus b. This would be 2a by pi, and this would be 1 plus b. You can cut off the 2a by pi's, and this will give you b equals to 0. Now use this thing, f dash x. So what is f dash x? F dash of x should be a pi by 2 into cos of pi x by 2. B is gone because, well, it's constant. Put half. If you put half, this side becomes root 2, and this becomes a pi by 2 into, and okay, so if x is half, then this becomes pi by 4. Cos of pi by 4 is basically 1 by 2. Correct? So this becomes a equals to 2 root 2 into root 2 is 4 by pi. So a is 4 by pi and b is 0. This completes the problem. Okay, let's erase this one. Let's go to the next problem. Yeah.
1995.
1995.
Pi to 2 pi. Integral of pi to 2 pi.
Integral of pi to 2 pi.
Box of 2 sin x.
Box of 2 sin x dx.
Yeah.
Okay, so we again have a classic greatest integer function Walla problem, right? So okay, we'll do it. Now the first thing is obviously I would try to reduce this, because you see this is not what all I want, pi to 2 pi. So we will first do, I think, y equals to x minus pi. This would make this integral 0 to pi, and then x should be y plus pi. So 2 sine of pi plus y, which I think would give you a minus sin x. So minus 2 sin x dx. Now you can again break this into two different portions first of all. So let's break it like this: 0 to pi by 6, because in this interval sin x is from 0 to half. So minus 2 sin x dx plus pi by 6 to pi by 2. In this interval we will have sin x from basically half to 1, correct, dx plus pi by 2 to pi 2 sin x dx. Notice in this part sin x, basically 0 less than x less than pi by 6, this would imply that sin x is between 0 to half, and that would mean that this is going to be true. So this would be 1, right? This should be 1. And if you do the negative sign, you basically get this 0 greater than minus 2 sin x greater than minus 1. This is why I have broken it into the interval 0 to pi by 6. Now you see the greatest integer that is less than or equal to minus 2 sin x is simply minus 1. So this becomes 0 to pi by 6 minus 1 dx. Similarly, this would be minus 2 because minus 2 sin x, again it is from half to 1, and it would be greater than minus 2 and less than minus 1. So pi by 6 to pi by 2, this should be minus 2 dx. Now again in this part we can do the same, but we will again try and simplify it. We will make the substitution y equals to x minus pi by 2. Okay, this is minus pi by 6. Okay, plus this one was there. This is minus pi by 6, this is pi by 2 minus pi by 6, which is I think pi by 3, and this is minus 2 pi by 3, plus this integral on which we are making this substitution, which will transform, I think, this into cos x, correct? This is minus 2 sin x. This will make it sine of x plus pi by 2. Yeah, sine of y plus pi by 2, which will make it into cos x, and we will have 0 to pi by 2 box of minus 2 cos x dx. This is what we'll have. Okay, we can erase this part now and continue it here. So I should be equals to minus pi by 6 minus 2 pi by 3 minus pi by 6 minus 2 pi by 3. Now again here we can break it into 0 to pi by 3 minus 2 cos x dx plus pi by 3 to pi by 2 box of minus 2 cos x dx. Similarly, here it should be, I think, 2, and here it should be 1, because it's a decreasing function, it goes the other way, I think. So okay, so this would give us ultimately minus pi by 6 minus 2 pi by 3. This should be, I think, well, minus 2 and minus 1 obviously, not 2 and 1. This should be minus 2 pi by 3, and this should be minus 1 whole into pi by 2 minus pi by 3, which is pi by 6. If you do all of this, I think you should get minus minus 5 by 8, which is the required answer. So this is our required answer of the integral. Okay. Yeah, the next one.
Minus 1 to 1 fractional part of a x dx.
This, right?
Yeah.
The year?
1998.
1998 IDJ. Okay, so we have this minus 1 to 1 fractional part of x dx, and by now we have understood how to do this kind of problems. So let's do like this, minus 1 to 0. Now fractional part of x is x minus box x, right? So write this. Do it same for the other interval 0 to 1. It is important to break it into consecutive integers, the interval of the integration, in order to evaluate box x correctly. So this should be minus 1 to 0. Box x is minus 1 here, so this becomes x plus 1 dx plus 0 to 1. Here box x is 0, so x is. Okay, so this becomes minus 1 to 0 x plus 1, so basically 2 plus x from 0 to 1 minus 1 plus this becomes half. 0 is 0, and then you have minus of, put minus 1 here, 1 by 2 minus 1 plus half. This means 1 minus 1 by 2 plus 1 by 2, which is 1. Which is the correct answer. Okay. Let's go to the next one.
0 to x ft dt is equal to x plus x to 1 t ft dt. Find f1.
Find f1. Okay, so what is the year?
1998.
98.
98.
We have to find f of 1. Okay, so again, this is a very typical problem, and we can perform integration, differentiation under the integral sign here, because these are integrals, and integrals with variables upon them, and where a continuous function is inside, you can differentiate them. So okay, differentiating this would give you f of x equals to 1 plus, now this thing, the upper limit is first differentiated and put inside, which is 0, minus the lower limit, which is this, and then put inside, so x of fx. For reference, please do see the Leibniz rule of differentiation under the integral sign. Solve for f of x here, bring this to this side, you get this, and therefore f of x basically becomes 1 by 1 plus x, and f of 1 basically becomes 1 by 2, which is your required answer. Okay, this is a pretty easy one. Let's go to this one. Yeah, next
one, pi by 4 to 3 pi by 4 dx by 1 plus cos x.
Okay. And here?
I think here is not written.
No problem. Okay, so we'll have some question mark. We'll put it there.
Yeah.
Okay, so we have pi by 4 to 3 pi by 4 dx by 1 plus cos x, correct? Now, again, an integral which you might have seen before, this kind of integrals are common, and when you have like 1 plus cos x or 1 plus sin x or something like that in the denominator, you would try to bring it to this form, pi by 4 to 3 pi by 4. Remember that 1 plus cos x, this thing can be written as 2 cos square x by 2, which in turn is this. Correct? And this is exactly the derivative of tan of x by 2, which means this is nothing but this. Now, once we have got this, we can put the values directly, and we can find tan of 3 pi by 8 minus tan of pi by 8. But we can simplify it further. Notice that this can be written as pi by 2 minus pi by 8 minus tan of pi by 8, which means this is cot of pi by 8, which means this is 1 by tan of pi by 8 minus tan of pi by 8. Simplify to get 1 minus tan square of pi by 8 by, do a 2 here and a 2 here, 2 tan of pi by 8. Notice that this is the formula of tan 2 theta just in reciprocal. So 2 tan x by 1 minus tan squared x, but just in reciprocal. So this should be 2 divided by tan of 2x, where x is pi by 8, so tan of pi by 4, which is nothing but 1, so answer is 2. Okay, pretty easy one. Next one. Yeah. Next one.
e to the power minus 1, 2 is e to the power 2,
Okay.
mod of ln of x by x dx.
Okay. So what is the year?
2000.
Okay guys, so like another problem of the same category. You have a modular sign. Basically you have to break it into intervals to understand what's basically going on here. You can first try this. Well, obviously ln x, in order for ln x to be positive, x must be greater than 1, right? So you can break it like this: e inverse to 1, and this should be minus ln x by x dx, because ln 1 is 0, and then you can do from 1 to e square, where this would be positive. And this would give you minus ln x by x, but again ln x and its derivative dx by x is already present here. If you do the substitution of y equals to ln x, this would be simply ln square x. So you can simply write this as ln x d of ln x, which would be ln square x by 2 from 1, and there is e inverse, and similarly this would be the same thing, ln square x by 2 from e square to 1. Okay, let's put the values. ln 1 is 0 minus e inverse. ln of e inverse should be minus 1, which is minus 1 whole square is half. You will get this, plus e square. So ln of e square is 2, 2 square is 4, 4 by 2 minus ln 1 is 0. This would give you half, this would give you a 2, I think, and this should be 5 by 2, which is your required answer. Okay. Next one.
f of x whole bracket of e to the power cos x
E to the power cos x
sin x
sin x.
when mod of x,
When is it a piecewise function?
yeah, it's a piecewise function,
Oh, okay.
or equals to 2, fx equals to 2,
We have to get this, I guess.
Yeah.
Yeah, it equals to 2 when?
otherwise
Oh, like for any other x, like this.
Yeah, yeah.
Otherwise. Great. What do you have to find?
2 minus 2 to 3 f of fx dx.
Okay. Okay, so we have this piecewise function.
It's 2000, yeah,
2000.
yeah, it's 2000.
Yeah. Okay, 2000, and we have this piecewise function, and we have to find this value. Okay, I'll basically do this first, because this is what I noticed right off the bat, because this is an odd function. That is, you have to notice, which is why I'm breaking it into the interval minus 2 to 2 plus 2 to 3. Now, minus 2 to 2, this fx is odd, you can check, because f of x is equals to f of minus x minus, because you can see here f of x is e to the power cos x into sin x, and f of minus x is nothing but e to the power cos x, because cos of minus x is cos x, but sin of minus x is minus sin x, and this gives you minus f of x. So this is an odd function, correct? And if this is an odd function, integral from minus 2 to 2 fx dx by property should be 0. And in 2 to 3 fx dx, since x is greater than 2, which is not inside this limit, so f of x should be 2. So this integral is basically 2 to 3 2 dx, which gives you 2 as the final answer. Pretty easy, right? Okay, next one.
Minus pi to pi
Yeah,
cos square x
cos square x
divided by 1 plus a to the power x,
e to the power x
a to the power x,
a to the power x
when a greater than 0.
dx.
Yeah, dx.
Done.
It's right.
Greater than 0. Here? Which year?
2001.
2001. Okay. It's another problem. So I hope all of you are noticing how things are repeating after so many years. Like every year, almost there is a question like this. If you've not guessed it yet, obviously we have to apply the formula of a to b f of x dx. So when you do that, you get this minus pi to plus pi. When you apply the formula of that, this cos square x remains the same, but this x becomes a minus x, because a plus b is 0 minus x, right? If you do that formula, so this becomes this. We have, now you can do the simplification, minus pi to plus pi, a to the power x cos square x by 1 plus a to the power x dx, which also is I. Add these two copies of I, you get 2i equals to minus pi to plus pi. You add this and this, you simply get 1, which gives you pi minus of minus pi, which is 2 pi. Therefore, I is equals to pi. Pretty simple. let's go to the next one. Yeah, next.
Integral of minus half to half
Hmm?
box of x
Hmm?
plus ln of 1 by x by 1
Box
minus
of,
box of x plus
plus
ln of
hmm?
1 by x by 1 minus x
1 plus
1 plus x by 1 minus x.
yeah, dx.
Yeah.
Okay, you have to find this value, this integral, right?
It's here is 2002.
2002.
Yeah.
Okay, so again, this is box of x, and in order to evaluate box of x, we obviously have to understand again the integer part, that it's less than. So minus half to 0, we will break it like this: minus half to 0 box x dx plus 0 to half box x dx, and this function I am going to do nothing. I will give you a second to understand what this function basically is, because we basically did it in the last example. Anyway, so in this interval minus half to 0, x is between minus half to 0, so the box of x should be minus 1, right? Minus 1 dx. Plus in this, the box of x should be 0, which is 0. And notice this is the odd function. What happens to odd functions when you have limits of the form minus a to a? They become 0, correct? 0. And this is 0, this is basically minus half into 0 minus of minus half, which is plus half, gives you the value of minus half, which is your required answer. Okay, let's go to the next one.
0 to 1
0 to 1.
root over of 1 minus x by 1 plus x dx.
Here.
2004.
Okay, so you have again integral like this: 0 to 1, root over 1 minus x by 1 plus x. Remember, in this type of integrals, the key observation is to understand what substitution do I make. I will choose the substitution x equals to, I think, cos 2 theta also works, but sin 2 theta also works. So I'll go with sin. And dx should be 2 cos 2 theta. This gives you 0 to pi by 2. Now this is your dx, you already got that. And now what happens to this part? So this becomes 1 minus sin 2 theta by 1 plus sin 2 theta. And like this into 2 cos 2 theta d theta, correct? So we have, okay, 1 minus sin 2 theta is cos theta minus sin theta whole square. 1 plus sin 2 theta is cos theta plus sin theta whole square. So this becomes this is minus right here, cos theta minus sin theta by cos theta plus sin theta into 2 cos of 2 theta d theta. This is your expression right now. Now how do you evaluate it? Well, first of all, you see that this is cos theta minus sin theta by cos theta plus sin theta. Cos 2 theta can be written as cos square theta minus cos sin square theta. So take the 2 outside, 0 to pi by 2 cos theta minus sin theta by cos theta plus sin theta into cos 2 theta is cos square theta minus sin square theta, which is nothing but cos theta plus sin theta into cos theta minus sin theta d theta. This thing's cut off, you get cos theta minus sin theta whole square, which is again this. So this should be 0 to pi by 2, 1 minus sin 2 theta. I hope you got that step, otherwise just rewind it. This and this remain, whose whole square is nothing but this, because that's how you got it in the first place. This gives you 2 into pi by 2 minus 2 times 0 to pi by 2 sin 2 theta d theta. This becomes, I think, pi, and this becomes okay, so we have to change the limits, and we did actually. I will have a correction here actually. X equals to sin theta, 0 is 0, and this should be pi by 4. Yeah. Correction guys, this should be pi by 4 because we have taken sin 2 theta. I was so focused on sin theta, I thought it should be pi by 2, but okay, so pi by 4, and this is pi by 2, and this should be again integration of sin 2 theta should be minus cos 2 theta, so plus cos 2 theta by 2 from pi by 2 to 0. If you put pi by 2 in cos 2 theta, it gives you cos pi, and if you put 0, it gives 0. So I think 1 minus 1 is 2. Okay, answer is this is the answer, and notice that should be pi by 4 not pi by 2. Only pi by 1. Okay, so that's it. so what is the next one?
Minus 2 to 0.
Yeah.
X cube
X cube
plus 3x square
plus 3x square
plus 3x
plus 3x
plus 3
plus 3
x plus 1 plus x plus 1
plus x plus 1
whole into cos of
bracket x plus 1.
Yeah,
right?
yeah, yeah.
Yeah, into
cos of x plus 1.
inside cos x
Yeah,
plus
yeah,
1. dx.
Yes, dx.
Okay, so this is the integral, and what year was it?
Here is not mentioned here.
Question mark another one. Anyway, so we have this integral minus 2 to 0, and then there is this huge expression we have, and to solve it by doing some basic transformations, like obviously x cube plus 3x square plus 3x plus 1, this is x plus 1 whole cube. Then you have a plus 2, and then you have x plus 1 into cosine of x plus 1 dx. It's very obvious, we should make the substitution of y equals to x plus 1, which would give us minus 1 to 1, this should be y cube, this should be 2, this should be y cos y dy. Minus 1 to 1 y cube dy, odd function, that is why I am writing it as a separate integral. Minus 1 to 1 2 dy plus minus 1 to 1 y cos y, again odd integral. The odd function in an integral of the form minus a to a. Both of these are 0. Only left with this 2 into 4. This is our answer. Okay, so let's go to the next one. Yeah, next.
Limit x tends to a.
Limit x tends to a.
Integration of, in the numerator,
Okay.
integration of a to x
A to x
fx dx
fx dx.
minus
Yeah.
Bracket x minus a by 2
Okay.
bracket close fx plus fa in a bracket
F of
x
x.
plus f of a
Okay.
whole divided by x minus a whole cube.
And we have to find f of x or degree or something like that.
Equals to 0. I suppose.
It is equal to 0.
Yeah, equals to 0.
Okay. I think we basically need to find the degree of fx or find out f of a. F of x basically. Anyway, let's proceed with the sum, we will understand. Anyway, this form is given and obviously you're going to apply L'Hopital. You know, you can see the video on the top right, that's the video where I explained why you can solve almost all the limits with the same rule. Okay, so we can apply this. So limit x tends to a. This one on differentiation would give you, I think, f of x simply because this minus, okay, this one differentiating would give you, first differentiate this one, x minus a by 2 differentiation will give you half into f of x plus f of a, and then again simply differentiate this but not this into f dash x divided by 3 times x minus a whole square equals to 0. Okay, limit x tends to a, differentiate again because it is again in the form of 0 by 0, f dash x minus half f dash x, half fa is basically 0, and again do this one. This one would basically again give you, differentiate this one, keep this one constant, so this is minus half f dash x, and again differentiate this one, keep this one constant, minus x minus a by 2 into f double dash x divided by 6 into x minus a equals to 0. Then f dash x, half f dash x, half f dash, this all of this basically cuts up to 0, x minus a cuts off here, you have by 2 here, so basically what you have is limit x tends to a, f double dash x by 12 equals to 0, which means f double dash a equals to 0. Now, for the function, basically what we are getting is the double derivative is 0, that means the function must be of the form linear, so fx must be a linear function of the form this, which means the degree of f of x is simply 1. This is the answer. Okay, let's go to the next one. So next one.
E to the power minus x
E to the power minus x.
fx
F of x
is equal to 2
is equal to
2 plus integral of 0 to x root over of z 4
yeah
e to the power 4 plus 1 dt.
dz. I will just write dz. I just wrote actually z.
Okay.
Year?
You have to find.
You know the year?
Yeah, I don't know the year actually. Yeah, 2010.
2010, okay, and you have to find what?
Find derivative at the point 2 of f inverse x.
F inverse x, so
F inverse, yeah,
basically
function.
this.
Yeah.
Okay guys, so we have this function where we have this equation given, and we also have to find the derivative of the inverse function of f at the point 2. Now, do not be frightened by saying derivative and inverse, because this is not really that much of a tough job once you know how to find out the derivative. So first of all, we will try and understand what this basically means. So if you have, let's say, if you set y is equals to f of x, this should mean that x is equals to f inverse y. This you have to understand. We are already assuming that yeah, the inverse exists for all the values of x in the domain of the function. Now from this equation, first of all, we are first going to find out the derivative of f. So derivative of f inverse. So what is the function f inverse y? This is x. So xy is equals to fx. If you differentiate both sides, you get dy equals to f dash x dx. Basically, you need to find out the derivative like this, and you will get dx equals to dy by f inverse of x, which is f inverse of f dash of f inverse y. This is going to be dx. So therefore dx by dy should be equals to 1 by f dash of f inverse y, which is the derivative of the inverse function basically at the point y, and the value is given by this. This is for our reference. Okay. Now from this equation, we'll use it later. From this equation, if you differentiate both sides, you get minus e to the power minus x f of x equals to, this simply becomes root over x to the power 4 plus 1. Correct? And okay, once you have this, you can find the derivative like this. You can take the e to the power minus x to that side, and you can write f dash x is basically equals to f of x plus e to the power x root over x to the power 4 plus. This is basically derivative. Why do we need this? Because we know the derivative of this thing, let's call it some value or answer, is nothing but 1 by f dash of f inverse of 2, because at the point 2, this is what we need. We need f inverse 2. Now, how do we find that? First of all, what is f inverse 2? So you can see if we put 0 here, if we put x equals to 0 here, you see that f of 0 is 2. So basically, f of 0 is 2, which means f inverse 2 should be 0. Correct? So we basically have to find 1 by f dash of 0. Put 0 here. Obviously, that would mean that f dash 0 is then f of 0 plus e to the power 0, 1, 0 plus 1, 1, 1. What is f of 0? Well, I think we can find it from here. F of 0 should be, I think, 2. This should make the answer 1 by 3. Right? Because f of 0 is 2, if you put 0 here, this integral becomes 0, this becomes 2, so f of 0 is 2. Okay, so our final answer should be 1 by 3, which completes the problem. Okay, let's go to the next one.
Limit x tends to 0.
Yeah.
1 by x cube. Now integral of 0 to x.
0 to x.
T ln of 1 plus t.
Okay.
By t to the power 4 by 4 plus 4 dt. Yeah. 2010.
Okay, so this is again a problem of the same sort where you can apply L'Hospitals, and we are going to do that. So we are going to simply consider this integral as the numerator and this as the denominator, and if you put 0 here, this is 0 and this is 0, because 0 to integral 0, the area is basically 0. Anyway, if you apply L'Hopital on both of this, so differentiating this integral would simply give you x into ln of 1 plus x by x to the power 4 plus 4, and differentiating this would give you 3x squared. Correct? This on simplified version should look something like this, and this should be 3x squared whole into x to the power 4 plus 4. Cut this off. ln of 1 plus x by x is 1 on when limit x tends to 0, and if you put 0 simply here, it should give you basically 0 plus 4, 4. So the answer should be 1 by 12. And it's a pretty easy question. So yeah, we are done with this one. Let's go to the next one again.
integral of from root over of ln2 to root over of ln3.
Root ln2 to root ln3, yes.
Now x sine x square,
X
sine x square, x
Sine
into
of-
sine x square by sine x square plus sine of
sine of
ln6
ln6
minus x square dx.
minus x square dx.
2011.
2011. Again, the first thought that you should have when looking at this integral is what substitution can I make and why is there an extra x in between all these signs. Obviously, you have to substitute for x square whose derivative is 2x, which is what they have provided you already. Correct? Put y equals to x square, then dy would be 2x dx. You should have this. The limit should be ln2 to ln3 now, and this should be dy, and you would have sine of y by sine of y plus sine of ln6 minus y dy. This should be your I. Now again apply the formula a to b f x dx. That way ln2 plus ln3 is simply ln6. So notice how this again turns into one of those problems. Sine of ln6 minus y divided by sine of y plus sine of ln6 minus y dy. And add these two copies of I, you get 2i equals to half. And when you add these two copies, the integral inside becomes 1. So basically ln2 to ln3 1 dy, which gives you half into ln3 minus ln2. Therefore, I should be equals to 1 by 4 ln of 3 by 2, which is the required answer. Okay. Let's go to the next one.
Integral of from minus pi by 2 to plus pi by 2
Yeah.
x square in bracket
Okay, in bracket
x square plus ln of pi plus x by pi minus x
pi plus x by pi minus x.
bracket close whole into cos x dx.
Year
2012.
2012.
Yeah.
Okay, so we have this integral again, and I can directly figure out that this is one of those integrals. That obviously this is an odd function. You should know it by now. This is an odd function, and okay, the first integral we have minus pi by 2 to pi by 2 x square cos x dx. This is basically what we have to find, because the other part, which is minus pi by 2 to pi by 2 ln of pi plus x by pi minus x cos x dx. This integral is 0. I leave it to you to find out, because this is basically an odd function. There is nothing to be checked here. This is an even function, so this becomes 2 times 0 to pi by 2 x square into cos x dx. And obviously we want to reduce it, make it 1 and make this 2, and do integration by parts. What do you get? We simply get, I think, integration of cos x is sin x, so you get x square sin x from pi by 2 to 0 minus 0 to pi by 2 2x into sin x dx. Okay, this becomes, let's say, 2. This is pi square by 4 into 1 minus 0. So basically pi square by 4 minus 2 times, and again we will do 1, 2. So put a bracket again, minus x cos x from pi by 2 to 0. So integration of sin x is minus cos x plus 0 to pi by 2. Again, derivative of x is 1 into integration of sin x, which is minus cos x. Thus there is a plus sign, which is cos x dx. This becomes pi square by 2 minus 2 into 2, 4 times. Now let's do this. Minus pi by 2 into cos pi by 2, 0. Minus 0 into this, and again this is a 0. This whole thing is 0 basically. Correct? And what you have for this integral, cos x integration is sin x, sin pi by 2 minus sin 0. Sin pi by 2 minus sin 0. So this basically becomes pi square by 2 minus, and you have sin pi by 2 1, this is 0, so this is the answer. And thus we have completed the problem. Next.
0 to half
0 to
half 1 by
half
2 x sin inverse x
x sin inverse x
all divided by root over 1 minus
x square
dx. Yeah.
dx. Clear?
1984.
Okay, so this is another typical example where you already have the derivative present and you know what substitution to make. If you know sin inverse x has a derivative of 1 by 1 root over 1 minus x square, so we will let y equals to sin inverse x, and this would obviously mean x is sine of y. Okay, now dy by dx here, dy would simply give you dx upon root over 1 minus x square. So the integral I basically turns, so first of all, when x is 0, y is 0, so 0. When x is half, y should be pi by 6, correct? Because sine of pi by 6 is half. So x becomes sine y, sine inverse x becomes y, and this whole thing becomes dy, which is a simple problem in integration by parts. So we will take this one as our first function, this one as our second function, and this will give us minus y cos y from pi by 6 to 0 on applying integration by parts, minus 0 to pi by 6. Differentiation of y, which is 1, integration of sin y, which is minus cos y, makes it plus cos y dy. Okay, this becomes minus pi by 6 into cos of pi by 6, which is root 3 by 2. And when we do the 0 part, it becomes 0, plus the cos-wise integration is sin-wise, so basically sin pi by 6 minus sin 0. Okay, so sin pi by 6 is 1 by 2 minus, and this becomes, I think, 12 pi root 3 by 12. Pi root 3 by 12, which is your required answer.